Good morning, everyone. Good morning. Am I audible? Everyone, hello, hello, hello. My voice coming to you? Am I audible, visible? Good morning, good morning. Good morning. Yes, Aranya, good morning. Okay, very good, very good. Yes. So what we were learning in the previous class? What we were learning? Good morning, Zamir. Good morning. Good morning. Good morning, Animation. Animation Hub. Your name is Animation Hub. It's interesting name. Change to correct name. Good morning, Manish. Good morning. Very good. Very good. Okay. So let us start now. What we have covered in the previous class, I think we were covering dot product. Good morning. Good morning, everyone. Good morning. We were covering dot product. We have covered dot product. Okay. So what is dot product? Dot product is represented by a dot. It gives you a scalar result. A dot B, which is also B dot A. Both is same thing. And this is given by magnitude of A, magnitude of B, cos of angle between them. This was the definition of dot product. We have done dot product. Is this clear? Dot product understood? Everyone, dot product is everyone. Is it clear? Okay. So now today we will start cross product. Today we will start cross product. This was dot product. Now we will start cross product. Cross product. This is also called vector product. The value of dot product is a scalar. The value of dot product is a scalar. But the value of cross product gives you a vector. But cross product gives you a vector. That's why the name is also vector product. Okay. First we will learn the definition. Definition of cross product. Definition of cross product. When you take cross product of two vector, you get magnitude of A, magnitude of B into sine of angle between them. In dot product, we were getting cos of angle between them. In dot product, A dot B or B dot A is AB cos theta. In cross product, we are getting AB sin theta. This is the magnitude of A cross B. This is the magnitude of A cross B. But cross product is a vector. Cross product is a vector. So we also get a unit vector in direction of A cross B. We also get a unit vector n cap in direction of A cross B. What is this AB sin theta here? This is the magnitude of cross product. Magnitude of cross product. And what is this n cap? Direction of cross product. Direction of cross product. Any vector can be written as magnitude into direction. So this is magnitude of A cross B. This is direction of A cross B. What is this n cap? N cap gives you direction of cross product. Now how to find n cap? How to find n cap? N cap is determined by right hand thumb rule. Right hand thumb rule. What is right hand thumb rule? We have covered right hand thumb rule in Excel vectors also. Same right hand thumb rule is used here. Same kind of right hand thumb rule is used here. Okay. How to find n cap? How to find n cap? By definition, it is perpendicular to both A vector and B vector. If we see the definition of right hand thumb rule, we will just see it. N cap will come perpendicular to both A and B. The cross product of A and B is perpendicular to both A and B. The cross product of A and B is perpendicular to both A and B. Suppose this is a plane in which plane of A vector and B vector. This is a plane of A vector and B vector. I am drawing a plane of A vector and B vector. In this plane, this is my A vector, first vector. This is my second vector, B vector. And this was the angle between A and B. So here I am drawing a plane containing A and B. In this plane, my A and B vector are arranged. Okay. Then the cross product can be decided by direction of cross product. can be decided by right hand thumb rule. Always use your right hand for all good deeds. Okay, so we will use right hand. Take the fingers of right hand in the direction of first vector. Curl the finger in direction of second vector. Thumb gives you direction of cross product. I will repeat. Keep the fingers of right hand in direction of first vector. Curl the finger of direction in the direction of second vector. Thumb gives you direction of cross product. So let me first draw it here. Then I will again explain the cross product direction. If I keep my fingers of right hand in direction of first, curl the finger of right hand in direction of second, then my thumb gives you direction of cross product. This is the direction of A cross B or direction of n cap. How to find this direction? This is perpendicular to both A vector and B vector. This is perpendicular to both A vector and B vector. How to find it? By right hand thumb rule. So let me see if there is one more pen here. Yeah. Okay. See, assume this black pen, this is a black pen and this is a pencil, silver and black pencil. Okay, these two are my vectors. These two are my vectors. I am arranging these two vectors like this. I am arranging these two vectors like this. You all are able to see these vectors. Okay, take your right hand. Keep the fingers of right hand in direction of first. I am assuming this black pen is my first vector. Black pen is my first vector. Arrange the finger of right hand in direction of first vector. Curl the finger in direction of second vector. Curl the finger in direction of second vector. If you keep your hand like this, you won't be able to curl naturally in the direction of second vector. So keep your right hand such that you are able to curl the fingers toward the second naturally. If you put your right hand like this, you will not be able to curl finger naturally in the direction of second. You need to keep hand like this. Okay. If you keep your hand like this, curl the finger in direction of second, then direction of thumb gives you direction of A cross B. Is this point clear? How to find the direction of A cross B? What is the right hand thumb rule? Is this clear? Right hand thumb rule. How to find the direction of cross product? Keep the finger of right hand in direction of first. Curl them in the direction of second. Direction of thumb gives you direction of cross product. Direction of thumb gives you direction of cross product. Okay. So how to find direction of cross product? Suppose these two vectors are exactly in the board plane. Let me draw the vectors in the exact plane of board. Okay, I am drawing the two vectors in the plane of board. Suppose this is my A vector, this is my B vector. They are in the plane of board. For an example, I am drawing the two vectors in the plane of board. Okay. Now, if I want to find A cross B, I will keep my finger of right hand in direction of first vector. Like this. I will roll the finger in direction of second vector. The direction of thumb is outward. Direction of third is outward. It is called outwards. Okay. Perpendicular to board, outwards. Outward direction is represented by a dot. This is direction of A cross B. This is direction of A cross B. To show outward direction, we generally use a dot. Okay, dot shows A cross B. And suppose I want to show inside direction. If I take B first, then A second, then A cross B is inward. Take the fingers in the direction of first. I am taking B as first, then A, B cross A will be inwards. Inward is shown by cross. This is inward. This is direction of B cross A. This dot shows outward. So these are the way to represent outward direction and inward direction. Cross shows inward direction, dot shows outward direction. And you can also see A cross B and B cross A are in opposite direction. A cross B is coming out, B cross A is in. So A cross B is not equal to B cross A. We have discussed here, A cross B is not equal to B cross A. A cross B is not equal to B cross A. They are actually inverse of each other. Okay. So A cross B is negative of B cross A. Why? Because direction of A cross B and B cross A are reversed. Direction of A cross B and B cross A is reverse of each other. Is reversed. Okay, so we have defined what is the cross product of two vector. What is the definition of cross product? A cross B is given by AB sin theta into n cap. AB sin theta into n cap. What is AB sin theta? This is the magnitude of the vector, magnitude of the cross product. AB sin theta is magnitude of cross product, and n cap gives you direction. N cap gives you direction. So definition of A cross B is AB sin theta into n cap. This is magnitude, this is direction. How to find direction of n cap? By right hand thumb rule. Keep the fingers of right hand in direction of first vector, curl the finger of right hand in direction of second, thumb gives you direction of cross product. Okay, and cross product direction is perpendicular to both A and B. Cross product direction is perpendicular to both A and B. If this is A and B in a plane, the direction of cross product is perpendicular to both A and B. Okay, and we have discussed here the property that A cross B, if it is out, then B cross A, it is inside. So direction of A cross B and B cross A are just reverse. So cross product is not commutative. Cross product is not commutative. Not commutative. Cross product does not follow commutative law. Cross product does not follow commutative law. A cross B is negative of B cross A. Is this point clear? Everything clear till this point? Everything understood? Tell me. Definition of cross product clear? Yes. Okay. Okay. Very good. Very good. Definition of cross product we have covered. Okay. So next point. Let us solve some simple question based on cross product. Very simple question based on cross product. Very simple question. If magnitude of A vector is 4, magnitude of B vector is 2, and angle between them is 60. Angle between them is 60. Find the magnitude of cross product. Find the magnitude of cross product. Find the magnitude of cross product. Find this magnitude of cross product. This is a very simple question. Just magnitude of cross product you have to tell me. Magnitude of cross product. Very good. Bless you, very good. Kavya Shri, very good. Bhaga Devi. Lachna. Zamir, very good. Everyone is giving me correct answer. Very good, Sahiti. Very good, very good. You need to tell me magnitude of cross product. Srinivas, very good. Ruchi, very good. Magnitude of cross product. Magnitude of cross product A cross B. It was A, B into sine of angle between them. A and B are just magnitude of A and B. So A is 4, B is 2. Sine of angle between them is 60. Sine 60 is root 3 by 2. Root 3 by 2. So 4 into 2 into root 3 by 2. This becomes 4 root 3. This kind of easy question may come for cross product. Okay. So cross product, to find magnitude of cross product, it is very easy. Okay. Now let us see the properties of cross product. Properties of cross product. Properties of cross product. First, cross product gives you a vector result, whereas dot product was giving you a scalar result. Cross product is giving you vector result. That's why the name is also vector product. So first property may be cross product gives you a vector result. Cross product gives you a vector result. Very simple first property. Cross product gives us a vector result. Second, cross product is not commutative. We have covered this, but I will again write this because it is property of cross product. A cross B is negative of B cross A. Hence, A cross B is not equal to B cross A. A cross B is not equal to B cross A. Cross product is not commutative. If you add A cross B with B cross A, you will get 0. Addition of A cross B and B cross A will give you 0 because they are negative of each other. So if you add these two things, you will get 0 because they are negative of each other. So vector product is not commutative. But we can distribute vector product. But we can distribute A cross B plus C. This is equal to A cross B plus A cross C. It follows law of distribution. I can distribute this cross product over the two numbers B and C. A cross B plus A cross C. I can open the bracket and multiply A with B and C like this. It is distributive but not commutative. Is this point clear? Second property, is this clear? Vector product is not commutative. You cannot commute A, B and B, A are not equal. Tell me, is this point clear? Yes, okay, very good. Very good. The next point, third property. Third property. Now we'll discuss about magnitude of A cross B. Magnitude of A cross B. See, A cross B magnitude is AB sin theta. AB sin theta. And what is theta here? Theta is angle between A vector and B vector. So angle between any two vectors is always between 0 and 180. Angle between any two vectors is defined only in the range 0 to 180. By definition, angle is between 0 and 180. So this sin theta will be positive. Between 0 and 180, sin theta is positive. Okay, sin theta is positive in first quadrant and sin theta is also positive in second quadrant. So this will always be positive. Mod of A cross B will always be positive. And anyway, because this is magnitude, so that's why it should be always positive. Magnitudes are always positive. But when sin theta is 0, the product will become 0. So sin theta is 0 for theta equal to 0 and 180. It means when vectors are parallel or anti-parallel, cross product is 0. For parallel or anti-parallel, cross product is 0. Parallel or anti-parallel, combinedly they are called collinear. Collinear vectors. It means parallel or anti-parallel. In this situation, when vectors are parallel or anti-parallel, cross product is 0. When vectors are parallel or anti-parallel, cross product is 0. Cross product of parallel vectors is 0. If cross product of two vectors is 0, they are parallel or anti-parallel. They are parallel or anti-parallel. There is a question on this concept. There are many questions on this concept. They will give you A cross B is 0. Then what is the angle between A cross B? It may be 0 or 180. Answer. Simple. So A cross B is 0 only when they are parallel or anti-parallel. But if angle is 90, that is A and B are perpendicular, cross product become maximum value. For perpendicular vectors, theta is 90, A cross B gives maximum magnitude, which is only AB. In this case, sin theta becomes, sin 90 becomes 1. Because sin 90 is 1, so A cross B is maximum. Maximum value of A cross B comes when the vectors are perpendicular. When vectors are perpendicular, yes. When vectors are perpendicular, A cross B is having maximum magnitude. If you draw the graph of value of A cross B, magnitude of A cross B with theta, magnitude of A cross B is AB sin theta. So if you draw graph of theta versus AB sin theta, you will get a graph of sin theta only. For pi it is 0, for 0 it is 0, and for pi by 2 it is maximum. Maximum equal to AB. So because magnitude of A cross B is AB sin theta, we are just getting a graph of sin theta. Okay, this is the graph of sin theta. For 90, the magnitude of A cross B is maximum. For 0 and 180, magnitude of A cross B is 0. So is this clear? When two vectors are perpendicular, their cross product gives you maximum magnitude. When they are parallel or anti-parallel, their cross product becomes 0. All this point clear? Parallel vectors, cross product 0. Anti-parallel vector, cross product 0. Parallel or anti-parallel, we call them collinear. Collinear vectors, cross product 0. If vectors are collinear, cross product is 0. If vectors are collinear, cross product is 0. Okay? And the value of cross product is maximum when angle is 90. Whereas in dot product, if two vectors are perpendicular, dot product was 0. Dot product was 0, but here cross product is maximum. This is some difference between vector product and vector product and dot product. Okay. Third property. Now we'll discuss third property. So we have discussed, I think this was the third property. Yes, this is the third property. So now we'll discuss fourth property. Fourth property. Cross product of a vector with itself, A cross A. If you cross product of a vector with itself, you get 0. Cross product of a vector with itself is 0. Why? Because angle between a vector with itself, if you draw two A vectors, then angle is 0 and sine 0 is 0. So cross product of two same vectors is 0. Cross product of A with A, 0. Cross product of B with B, 0. Cross product of a vector with itself, 0. Note this property. Cross product of a vector with itself, 0. Because angle of a vector with itself is 0. Fifth, cross product of unit vector. Unit vectors I cap, j cap and k cap. Now we will learn about cross product of I cap, j cap, k cap. Learn about the cross products of I cap, j cap, k cap. What will be I cap cross I cap? What will be I cap cross I cap? What will be I cap cross I cap? Tell me, what will be I cap cross I cap? Very good, Kavita. What will be I cap cross I cap? Vijay, very good. Durga, very good. Everyone is giving correct answer, very good. And the reason is because they are same. A vector multiplied with itself, cross product with itself gives you 0. Cross product of a vector with itself, 0. So I cap dot I cap 0, I cap cross I cap 0, j cap cross j cap 0, k cap cross k cap 0. K cap cross k cap 0. Write this. I cross I 0, j cross j 0, k cross k 0. I cross I 0, j cross j 0, k cross k 0. But if I multiply I with j, I get k. If I multiply I with j, I get k. If I multiply k with I get j. If I multiply j with k, I get I. There is a cyclic law. See, we are going in direction of clock. If you go clockwise from ijk, I cross j gives you k. I cross j gives you k. K cross I gives you j. K cross I gives you j. J cross k gives you I. J cross k gives you I. If you go in cyclic direction, you will get positive result. Okay. Perpendicular of I and j is k. Perpendicular of k and I is j. Perpendicular of j and k is I. But if you go in anti-clockwise direction, you will get negative sign. J cross I is minus k. I cross j, you are going positive direction, so you will get plus k. But if you go j cross I, you will get minus k. Similarly, k cross I is plus j, but I cross k, you are going in anti-clockwise direction, I cross k, so you will get minus j. When you go in clockwise direction, you get positive result, but if you go in anti-clockwise direction, you get negative result. Similarly, k cross j is minus I. Okay, why this is happening? Because the three vectors I, j, k are perpendicular. I, j, k are perpendicular. The I and j, when they are cross product, the direction is outside, that is the direction of positive z axis. X, Y, Z axis follows the right hand thumb rule. The direction of positive x into direction of positive y gives you direction of positive z. I cross j gives direction of k. The three are mutually perpendicular. These three are mutually perpendicular. I, j, k are mutually perpendicular. So this is cross product of unit vectors. We have discussed the cross product of unit vectors I, j cap, I cap, j cap, k cap. Is this clear? We have discussed cross products of unit vectors I cap, j cap, k cap. Okay. So if we know the cross product of unit vectors, now we can find the product of vectors in component format. Product of vectors in component format. Product of vectors in component. This is the fifth or sixth property, whatever the number you should write. Product of vectors in component format. Sometime they will give you vector in component format. Like this is your A vector, which is having x component AX, y component AY, z component AZ. In I, whatever is written, that is the x component of vector. In j, whatever is written, that is the y component of vector. In k, whatever is written, that is the z component of vector. This is x component, y component, z component, or component in x direction, component in y direction, component in z direction, or projection in x direction, projection in y, projection in z. Okay. Similarly, the second vector is also given in component format. bxi, byj, bzk. Suppose the vectors are given in this format. This is called component format, and we want the cross product. We want the cross product A cross B. Okay, so for cross product here, I will first multiply I with every 3 term here. Then I will multiply the j cap expression with every 3 term here. Then k cap expression with every 3 term here. So in that way, I will get 9 term. First multiplied with 3 term. Second multiplied with 3 term. Third multiplied with 3 terms. But out of this 9, I and I cross product 0, j and j 0, k and k 0. So there are 6 terms, and problem still becomes very large, very difficult. So to make it very easy, we have devised a way to write the cross product in easy format. To find the cross product, we will use this method. This is called determinant. Write two parallel lines and write I, j, k in the first row. This is called row. This is called row. So we are drawing the first row of determinant. The first vector is A. So start with components of A. X component of A, AX. Y component of A, AY. Z component of A, AZ. Write the component of X. Then write the components of second vector, which are BX, BY, and BZ. So I am writing the X and Y components of X and Y. Okay, A and B. So start with IJK, write X components, write components of A vector, write component of second vector, component of first, component of second. Create this determinant. Now this determinant has 3 rows and 3 columns. These are called row and these are called column. And this complete expression is called determinant. Determinant. No one will ask you what is the name of this expression, but I'm just saying giving you the name of the expression. Okay, now we will open the determinant. how to open the determinant. That is important thing. How to open the determinant. First, start with first letter. I will multiply this row with the terms. Start with I cap. Right, I cap. Then multiply this. Going in down direction, you will get positive sign. Going in up direction, you will get negative sign. So I remove this row and column, including I. Take cross product of other two. AY BZ. So it will be AY BZ. Remove the row of I and column of I. Whatever the terms are left, do cross product. AY BZ. If you go from down to up, you will apply minus sign. Minus BY AZ. So up to down positive, down to up negative. Up to down positive, down to up negative. AY into BZ, then BY into AZ. If you go from down to up, put a negative sign in between. So there should be a negative sign in between. I am putting the negative sign in between. Okay. So I into AY BZ minus BY AZ. Now start with J. Second term we will start with J. I am writing a plus sign here. Remember, I am writing a plus sign here. Some books say there is a negative sign here, but I will use a positive sign here because I will go always from the next term. So multiply J with AZBX. Remove this row and column. Then you are left with this 4 term. AX BZ, BZ, AZ. So I will multiply AZ with BX. Then put a negative sign, BZ with AX. So if you are multiplying J, then in J, there will be only Z and X multiplication of A and B. Z and X. Okay, starting with J, AZ BX minus BZ AX. The last starting with K, I am multiplying K. So remove this row and column. You are left with this 4 term, AX BY minus BXAY. If you add these 2 terms, add these 3 terms, you are getting cross product of A and B. So it looks very difficult to open the determinant, but with practice it becomes very simple. If you do 1 or 2 questions, then it will be very easy. So write down how to find the cross product in vector in component format. Note down this determinant. Cross product in component format. Cross product in component format. So Durga is telling me they have noted. Now let us do some practice for cross product. If A vector equal to I plus 2j plus k, I plus 2j plus k, B vector equal to 2i plus j plus k, 2i plus j plus k. Find A cross B. We will find A cross B. So vectors are given in component format. We will find A vector cross B vector. A vector cross B vector is given by determinant of I jk, determinant of I jk, then xx component 1 2 1, then yy component 2 1 1. Okay, sorry. Then first vector xyz component, second vector xyz component. Okay, A vector ijk, component of A vector 1 2 and 1, component of B vector 2 1 1. Now I will open up the determinant. So I will start with I. So remove this column and this row. What we are left? We are left with 4 number. 2 into 1. I multiplied with 2 into 1. Then minus 1 into 1. Okay. So I am multiplying. Taking this I, multiplying 2 into 1 and 1 into 1. Putting a negative sign in between. This is the coefficient of I. Then the second term, j cap. If you want coefficient of j cap, remove this row and column. J cap, remove this row and column. You are getting 1 and 1, 2 and 1. So for j, I will start with this. J, I will start with Z. 1 into 2. 1 into 2 minus 1 into 1. Okay. So for J, I will start with Z component. So this 2 into 1. Then this 1 into this 1. This 1 into this 1. A negative sign in between. 2 in 2. Sorry. 2 in 1. Then 1 into 1. This is J. Then last K. K component. I will remove this row and column. So I am getting this two term. I am getting this two term. So 1 into 1 minus 2 into 2. K cap into 1 into 1 minus 2 into 2. Okay, tell me, is this clear? Now just solve this. Now just solve this. So what will left? 2 into 1, 2 minus 1. 2 minus 1, 1 I cap. 2 minus 1, 1 j cap. And 1 minus 4, minus 3 k cap. This will be answer. 1, 1 minus 3 k cap. Some are giving correct answers. Very good. Very good. So Naidu is asking me here negative j cap should be written. No, Naidu. I am starting j cap. For j cap, I am starting with the Z first. For J, I am starting here. I am starting with 2 into 1, then 1 into 1. Is this clear? Some people write J and multiply this way. 1 into 1, 2 into 1. Then they put a negative sign here. If I am writing X component, then I am starting with Y. If I am writing Y, then I am starting with Z. If I am writing Z, then I am starting with X. So X, Y, Z I am following in cyclic way. That's why there should be no negative sign here. Okay? Okay. Yes. So this is how we find the cross product in component formula. Let us do one more question. Okay. You will try this question on your own, then I will give you the answer. Question. Find A cross B if A vector equal to 3i plus j minus k, B vector equal to I minus j minus k. Find A cross B. Find A cross B. Data is changed. Find A cross B. Find A cross B. Try this once, then I will give you the answer. Find the value of A cross B. Okay, we will check. Some answers are coming. Very good. Very good, Srinivasa. Very good, Plessy. Okay, Strom. We will see. Okay. So I will also start here. A cross B, it will be I, J, K. Then the components of first vector, which are 3, 1, minus 1. Then component of second vector, which are 1, minus 1, minus 1. Now I will open up the determinant. So I into, remove this row and column, I into 1 into minus 1. I into 1 into minus 1, 1 into minus 1 is minus 1. Then negative of minus 1 into minus 1. Minus 1 into minus 1 is plus 1, but I put a negative sign in front of it. Minus into minus, minus 1 into minus 1 is plus 1, but I need to put a negative sign in between. So I will get a minus 1 here. Then J. For j, I will start with z. For y, I will start with z. -1 into 1, -1. Then 3 into -1, -3. I will put a negative sign before it. This is j component. K component, 3 into -1, -3. K component, I am finding K component, so removing this is the 3 into -1, then minus of 1 into 1, which is 1. Just solve this. So -1, -1, -2. This is -2i. This is +3, -3 plus 3, +3 -1, 2j and -4k. This is the correct answer. -2i plus 2j -4k. Very good. A lot of you are giving me correct answer. Very good, very good. Everyone is correct. बहुत बढ़िया. Shabash. Very good. Okay, so now we know how to find the cross product of two vectors. Let us do one more question. One more question of cross product. If r vector equal to I plus j plus k and f vector equal to 2i minus j plus k. 2i minus j plus k. Find torque, which is defined by r cross f. Find the torque vector which is defined by r cross f. So in this question I am asking you to find torque, and radius vector, r vector and f vector are given. The formula is also given. You just need to find r cross f. Do this question. Find r cross f. So this is like application of cross product. Why cross product? We are learning cross product to find torque in this kind of expression which require cross product. In this question I am asking you cross product. Find cross product. I plus j plus k is r vector and f vector is 2i minus j plus k. Find the cross product. Find r vector cross f vector, which is torque. Answers are coming. Very good. Okay, Vijay. So let me start also. R cross f, which is torque, that will be I, j, k. Components of r vector 1, 1 and 1. Components of f, which is 2, -1 and 1. Now I will open the determinant. I into 1 minus of -1. Okay, I into 1. Then this is -1. I will put a negative sign in between. Plus j. For y, I will start with z. 1 into 2. Then -1. Then k. -1, -2. So I am getting, this is -1, minus of -1, plus 1, 1 and 1, 2. So 2i plus j minus 3k. 2i plus j minus 3k. 2i plus j minus 3k. This answer, 2i plus j minus 3k. Very good. Everyone is giving me correct answer. Very good, very good. बहुत बढ़िया, शाबाश. Is this clear? So everyone is giving me correct. That means it's very clear. Okay, very good. So we know how to find the cross product when vectors are given in component format. And if they are giving vectors with magnitude and angle, even then we can find the cross product, which is mod A mod B sin theta, magnitude of cross product. Okay. So now we will learn more properties. So which number property was this? This was, I think, 7th or 6th properties. Cross product, product 6th property. So now we'll cover 7th property. Write the 7th property. Write the 7th property. 7th is more like a application, more like a application, more like a application. If you know how to find the cross product like this, like if they are giving you vectors in terms of components, component format, they are giving you vector, then we can find the cross product. Just now we have done this. Magnitude of cross product is given by magnitude of A, magnitude of B, sine of theta. So in order to find sine of angle between two vector, we can take magnitude of A cross B divided by AB. Magnitude of A cross B divided by AB. Magnitude of A cross B divided by AB. Vector A by A is A cap, and the second B vector by B is B cap. Vector divided by magnitude is unit vector. So mod of A cap cross B cap, mod of A cap cross B cap gives you sine theta. And remember, cos theta was A vector dot B vector upon AB. So we can write cos theta is A cap dot B cap. So mod of A cap cross B cap, sine theta. A cap dot B cap, cos theta. If you take cross, you get sine theta. If you take dot, you get cos theta. And one more property we know about sine theta and cos theta. One more property. A vector A cap cross B cap square, A cap dot B cap square. This will be equal to 1. Sin square theta plus cos square theta equal to 1. Sin square theta plus cos square theta equal to 1. Mod of A cross B square, mod of A dot B square. This gives you 1. We can find the sine of angle between two vectors using cross product. Okay, but cross product is very difficult to calculate now. So for finding angle between two vectors, we will prefer dot product. If you want to find theta, which will be, if you want to find theta, then that can be written as cos inverse A dot B upon AB. Dot product is easier to do, so we will prefer this method to find the angle. But if someone insists on doing cross product, then you can find sine theta using cross product. Okay? So we can find sine theta. This is the 7th property. 8. Remember, A cross B is mod of A, mod of B, sine of angle between them, and n cap also. I am not writing magnitude here, so I will apply n cap here. What is n cap? N cap is unit vector perpendicular to both A and B. So if you want to find n cap, which is unit vector perpendicular to A and P, in order to find n cap, what we can do? We can write A vector cross B vector upon AB. A vector cross B vector upon AB. AB sine theta, sorry. AB sine theta. A vector cross B vector upon AB sine theta. A vector cross B vector upon AB sine theta. A vector, B vector, if you divide by A and B, this is A cap cross B cap divided by sine theta. This gives you unit vector perpendicular to both A and B. So we can find unit vector which is perpendicular to both A and B using the cross product. This is another application of cross product, to find a vector which is perpendicular to both A and B. This n cap is a vector which is perpendicular to both A and B. How to find n cap? A cross B upon AB sine theta. AB sine theta is nothing but magnitude of A cross B. A cross B upon magnitude of A cross B. Okay. The next point. See, A cross B is perpendicular to both A and B. A cross B is perpendicular to both A and B. A cross B is perpendicular to both A vector and B vector. Okay. Then if I take dot product of A vector with A cross B, what I should get? A vector and A cross B, they are perpendicular. This vector and this vector, they are perpendicular. So what will be dot product? What is dot product of A vector with A cross B? Tell me, I am waiting for your answers. Very good, strong. This should be 0. Why 0? Because they are perpendicular. A cross B is perpendicular to A vector. So cross dot product with A, 0. Similarly, B vector dot A cross B, this is also 0. And A plus B and A minus B lies in the plane of A and B. If you add A and B or subtract A and B, they will be in plane of A and B. Okay, so A plus B dot A cross B is also 0. And A minus B dot A cross B, this is also 0. If you subtract or add A and B, you get a vector which is in the plane of A and B, which is in the plane of A and B. A plus B is a vector in plane of A and B, that is again perpendicular to this, so dot product 0. A minus B is also in plane of A and B, which is again perpendicular to A cross B, so again dot product is 0. So remember these properties. Remember these properties. Okay, so we have covered some properties of cross product, and one or two properties still left, but I have a next class, so we will stop here, and we will cover the next few properties. Some area regarding properties are left. We will find area of parallelogram and area of triangle using the cross product. So only those properties are left, and all others are okay. Okay, so let us meet in next class. Thank you all of you. Thank you everyone. Bye. Take care.